Madam, I welcome you on behalf of the Department of Commerce, Davangere University, Davangere. So before going to the address by Madam, just I'll brief up the topic. Expectations from AI in HR is sky high now. Artificial intelligence offers a platform to engage the employees as co-creators of a strong, smart, and advanced workplace culture. So please, yeah, the steady progress has transformed the way of employees pursues their jobs, work relationships with the colleagues, and their contribution towards the employees' contribution towards the company's growth. Organizations are adapting artificial intelligence into their human resource processes at varying rates. It is clear to see that the technology will have a lasting impact on the fields as it becomes more widely accepted. For this reason, it is important that HR professionals prepare themselves for these changes by understanding what technology is and how it is applied across various functions. However, Madam will further elaborate on this topic in a simple way. Before that, I would like to request Dr. Sirapa to introduce the Madam.
Okay. Good morning, one and all. Sir, audible, sir? Satnayana, sir.
Yes, sir. Yes, sir.
Okay. Good morning, one and all. It's my honor and to privilege to introducing today first session's resource persons, Dr. Cynthia, Madam. First of all, I would like to congratulate to Cynthia, Madam, because Cynthia, Madam is one of the NEEP committee member of the state. I would like to congratulations, Madam. And
from tomorrow, she'll be the director for management department.
Tomorrow and onwards.
Yeah,
tomorrow
yeah.
and onwards.
Yeah.
Okay. And at the same time, with the permission of the coordinator in this platform, I would like to congratulate our senior professor, Department of Commerce, and Register Evaluation, and former director of IPSC of Davangere University, Professor Anita Madam also. Why? Because Madam also one of the member of NEEP committee of the state. I congratulate to Madam in this platform. Anita Madam.
Thank you, Sirapa.
Okay, Madam. Thank you. And I am going to introducing today first session's resource person, Dr. Cynthia Madam. Cynthia Madam is a professor of business management, Bangalore University, Bangalore. And Madam is Dean of Commerce and Management, Bangalore University, Bangalore. And at present, Madam is working as a professor in a Department of Management Studies, Bangalore University. And she has completed her master's in business administrations and doctoral degree in management studies. She has over 30 years of teaching experiences with 22 years of MBA teaching. She has published more than 100 articles in several national and international journals. She has successfully guided 13 PhDs and presently 8 research scholars pursuing a doctoral degree under her guidance. Madam has been a keynote speaker and chairperson in the technical sessions of national and international conferences. Madam has conducted workshops on media management for managers and project management. And Madam specialization is international business and quantitative techniques and systems. And Madam is writes for newspapers and website. Currently, she holds the responsibility of coordinators for management studies at Gnana Bharati campus. And presently, Madam has to take an additional responsibility, the warden of Central College Ladies Hostel. So, and I think tomorrow and onwards, Madam is going to the directors of MBA department in Bangalore University, Gnanabhati. I welcome you, Madam. I welcome you, and I over you to this first session of today. First session, the artificial intelligence that is artificial intelligence in HR, that is selections and predictions. I welcome you, madam, and I overview of these first sessions. Thank you, one and all.
Thank you, sir. Thank you, Sirappa, sir.
Welcome you, madam. Welcome you, madam.
Respected Dr. Anita ma'am, Dr. Srinivas Kilara, Dr. Lakshman, Dr. Sirappa, Dr. Satyanarayana, and any other faculty that I may have missed. Also, all distinguished participants. I'm very pleased to be here because all of you are my friends. So it is like coming to a relative's house from Bangalore on a visit. This is how I feel. Anyway, we will go on and we will start this thing. Excuse me a minute. One minute. I'm sorry, someone started welding in the behind. Okay, so we are talking about artificial intelligence and we are talking about selection and prediction. First of all, what is selection? What is prediction? What is its importance in human resources management? Human resources is all about people. You can manage by machines by regular maintenance. You can handle your cash by good management. You can handle your procurement, marketing by good management. And good management by whom? By people. So if you do not manage well, your business will fail. To manage well, whom you require? Good people. What do you mean by good people? People who are qualified in that particular sphere. So when we select someone, when we recruit someone, when we predict and say, we are going to have such a project. And for such a project, I require 10 people. And the qualification of each person is like this. Let us say we are construction people and we are going to build an underpass in Bangalore city. So what kind of people do you require? You require top people who plan. There has to be a finance manager. There has to be a project manager who can manage everybody because there has to be one leader. And then there has to be an maestries. There have to be someone who is non-skilled and meant only to dig the work. So a gamut of requirements we have. So for all this, suppose for all these requirements, human intelligence many times is not sufficient. Why is it not sufficient? See, previously, if I were to be in Mandya and do a small job, say a road work, I would look for people in Mandya. I would be a localite and I would know everybody in Mandya. So I would say, Mr. This one is good for this, and I would call. But today, if I'm in Mandya and I'm given a work, I will not in Mandya, I will look for a better person who will do for me at a better rate from anywhere from Bangalore, from India, from anywhere in the world. Why? Because at my fingertips, I have the internet. So if I say, for example, I'm going to make an underpass in Mandya, and I find that somewhere in South India, say in Kanyakumari, they are making something called a magic box. A magic box is a cube that is made of concrete. It is factory made. So when you want to make an underpass, you just dig the tunnel and instead of building the concrete walls there, you bring the factory made magic box and fit it there. So suppose since I have internet at my fingertips and I'm in Mandya, I will look on the online and see the closest place may be, say, somewhere near Kanyakumari. There's a factory which makes excellent magic boxes at very reasonable rates, and the transportation can be done because we have a very good railway network in India. The transportation for this magic box can come from Kanyakumari to Mandya, because Mandya also has connectivity. At a minimum rate, it can come. So what I will think today, take the local laborers in Mandya, maybe one engineer there, but I will not build it. I will only dig the tunnel, bring the magic box from Kanyakumari. So I'm just giving you an example to tell you that today human intelligence is not enough, because we are dealing not with small data. We are not dealing with only Mandya. We are not dealing with only Bangalore or only Davangere. We are dealing on a global scale. So this data gets a name called big data, or sometimes we call it data lakes. Imagine a lake of data, nadiyashtu data. So who can swim in it? So like that, human intelligence is not enough. That is why we have artificial intelligence. So we will take a look at what is artificial intelligence. It is simulation of human intelligence. What do you mean by simulation? Suppose you go to a driving school and they're afraid to give you the car to be on the road. They are going to train you on the computer system. You sit there and it is like you are driving. Suddenly, you can see a screen and you can see the road in front of you. So you press enter and it looks as if the road is moving, or you are moving on the car. Imagine you're a driver and you're moving on the road. Suddenly, one dog runs across. You're supposed to brake. Suddenly, there's a right turn. You're supposed to take a right. You're given a steering wheel instead of the keyboard and you go right. And there's a left and you go left. On the screen, the simulation of driving. This is virtual, simple. In simple terms, it is virtual reality. So artificial intelligence is this is simulation. In the classroom, you give an experience of a real world situation. So artificial intelligence is basically simply simulation of human intelligence in machines. So what do these machines, are they machines simple? No, they are programmed. How are they programmed? Let us see. Once again, I'm not sure. Okay. So first of all, when I used to teach computer systems 20 years ago, I used to make fun in the class. Can a machine think? And then I would say, no, a machine cannot think. Then I would say, can a machine learn? Can it rationalize as opposed to human beings? Today, I have to redo my thoughts. Why? The artificial intelligence has become so much advanced that today, can a machine think? I have to say, yes, perhaps. And it can learn, yeah, 100%. Can it rationalize? It will rationalize in the way you have programmed it to think. Imagine there is a robot. Okay, a robot is maybe it's a security robot. So all security issues are programmed into the robot. What can be the danger? For example, if if someone passes, and what happens is the light, as the human being passes a particular sensor, the sensor says, this is so hot. It must be a human being. The body heat is 98. So it must be a human being. And or the height is so much. So it must be a human being. Suppose a dog passes, the alarm doesn't go off. The security person knows. For example, if how much hot can weather be? This room can be maximum, if it is Raichur. My students in Raichur are telling me, Gulbarga, they cannot even hold this thing, phone for their classes, because it is so hot, it seems. It is 40 degrees, they were telling me. So maximum how much the weather can be in India, say 40 degrees. So a robot has sensors of heat. Suppose I have a robot in my house and I've left it to guard my house. And the robot senses that the temperature here, there are heat sensors in the robot. And when the temperature becomes more than 40 degrees, then the robot says something is wrong. So the robot is programmed. When the temperature becomes more than 40 degrees, dial the fire engine 101, because obviously there is fire. So the robot will automatically dial 101, and there's a recorded message saying, this is from this house, please come, there is a fire. So these are the simple ways in which the artificial intelligence is used in many things, in simple computers, in things like robots, etc. And you understand, instead of talking out what I have written here, I would like to explain. See, when here, if you see the last sentence in my slide, it says decision making. Just now I told you how, a robot made a decision. The robot sensed, the heat sensors in the robot sensed that the temperature in the room is more than 40 degrees. If it is more than 40 degrees, it has become 50 degrees, danger. Like they give orange alerts, red alerts. So it is told, for example, when it is 45, 50, dial 101. So the robot made a decision based on its programming. Okay. Then give another situation. I've kept a robot in my house and I have programmed only my son's picture, my daughter-in-law's picture, my husband's picture, my picture, 4 pictures. So the robot will see, okay, this is ma'am's son. It will press a button, allow, open the door. Anyone else? I do not recognize this face, because only 4 faces are taken, a picture of only 4 faces, and it is in the robot's memory. So I will tell you as I go further how it deciphers a picture. How does it say voice recognition or facial recognition? So the robot will see the picture and says, this is not one of the, I'm not supposed to allow. No. Or if someone comes, say my son is wearing or I'm wearing a mask like this, and then the robot doesn't recognize me. So I said, I have a name for the robot. Say I'll call him Marcus. Marcus is my dog actually. So I said, Marcus, it's me. So my voice I have recorded and I have put it in the robot's memory. So when the robot, my dog has come because I said Marcus. Okay. So when I say Marcus, it's me, my voice, it will match to the voices that are there in the memory, and says this voice matches one of the voices. So when it matches, I'm supposed to open the door. And how to open the door? It doesn't say open the door. When a voice that I hear, when the voice sensor understands the voice and matches it with the one in the database, then press this button. It doesn't say open the door because it cannot rationalize, but it says, this lady says, hi, Marcus. So you can call Marcus anything, but the voice is matched to the voice in the database. And then when the voice matches, press the button. If the voice doesn't match the button, keep quiet. If there is a persistence, if there is so for example, there's someone talking outside the door for more than say 5 minutes, then the program is there. Press the dial 100, dial the cops. You see, for us it will be the robot recognize that there is a robber and it dialed the police. But for the robot, I hear voice. this voice I will match with the voice in my database. If the voice matches, press the button. If the voice doesn't match, wait. If the voice you keep on hearing for 1 minute, wait. If you keep on hearing it for 2 minutes, wait. If you keep on hearing it for 3 minutes, wait. If you keep on hearing it for 4, wait. If you keep on hearing it for 5 minutes, dial 100. You understand? This is how artificial intelligence works. Okay. Now we are talking about the next slide. Am I clear, sir? Okay. Artificial intelligence refers to the simulation I told you of human intelligence. The goals are learning, as I told you, learning. The robot has learned something. Then it has reasoned. How I told you, match the voice you hear, the sound sensors, whatever they hear, they will capture that sound, match it to the sound in the database, then take action. And then perception. Perception is the action that the robot has taken. Now, artificial intelligence today is used across different industries, and most popular is finance and healthcare. Now, I'll give you an example. We have SEBI, isn't it? Now, SEBI has been made because people were playing, to use the capital market, you have to be clever. But then clever people need not always be honest. So people had started using the stock exchange as a floorboard for speculation that was uncontrollable. We had Harshad Mehta scam, Ketan Parikh scam. We had so many scams. Many scams are hidden. The scams which we know I'm talking about. So, for example, whenever there is an activity, let us say now we are a group of people. I'm a teacher and you're my students. So I say, see guys, I have shares of say Lenskart. My specs is from Lenskart. We'll take this example. I have shares in Lenskart. I want to make some money. So we are about 100 people, let's imagine, and say, guys, we will create an artificial demand. So I will tell the first bench, start buying, man, buy 10 shares. Then after 2-3 minutes, you buy, man. So we are 100 people. In 1 hour or 1.5 hours, say 2 hours, 100 of us have started buying the shares, small amounts. Okay, maybe the people who bought first have sold also, but no, we will buy the shares and keep quiet. So there is people are watching in the share market. They'll say somebody is buying shares of Lenskart. I think they have some inside information that something good is happening in Lenskart. Maybe management is changing, or maybe they have got a new project, some insider information somebody has got, and people are buying. See, my goodness, 100 people have bought the shares of Lenskart. So the Lenskart shares, by the time 2 hours are over, have risen up. Instead of, say, the share was 10 rupees, and when we started, it was 60 rupees. Suddenly, the share became 120. So at the end of 102 hours, all of us sell our shares. Our shares 2 hours ago were 60. Now they are 120. So each of us, thanks to y'all, my 100 shares, instead of 60 into 100, I got 120 into 100. Now, these kind of things cannot be chased or monitored by human intelligence. That time, machines are necessary. Artificial intelligence tracks any unnecessary activity in the stock exchange. This is unprecedented and strange activity. What I initiated with y'all is strange activity. It is not legal. Because I want to get more money, I'm asking y'all to help me out. So that is not correct actually. So when there is some illegal activity like this, immediately artificial intelligence alerts the SEBI and says, see, stop it. Okay, SEBI sends warning signals and the activity is stopped. Okay, then healthcare. See, every disease, I will, about healthcare, I'll talk when I come later on. So there are some weak artificial intelligence and strong, strong artificial intelligence systems. Weak artificial intelligence are simple, which do simple tasks. I'll demonstrate after some time. But strong intelligence, strong artificial systems are there which can do complicated tasks. Okay. Now, see, a machine in artificial intelligence acts as a blueprint of the human mind. I will explain to you. See, instead of, see here, you can see artificial intelligence rationalizes, taking action, takes actions, etc. Imagine you have a bike and the bike is not starting. Human intelligence tells you, first what you have to do, have you put it on? Turn the key, switch on the ignition. First thing, okay, you have switched on the ignition, you forgot to this thing, the bike starts over. Second case, you switched on the ignition, bike didn't start. You started kicking, bike didn't start. So you'll say, let me check whether there is petrol. So you open the tank, petrol tank, and you check whether there is petrol. Okay, petrol is there. Still it is not starting. Then there's a tube which goes from the petrol tank to the engine. You will remove that and see, you will blow it and put, okay, petrol is going. Then what is, so it's not starting. Next, let me check my spark plug. You remove the spark plug, you use something, you clean it and you put it. Still it is not starting. Then you say it is time to take to a mechanic. Self-help is not helping me. You go to a mechanic will do the same things that you did. He will check your ignition, he'll check your fuel, he'll check your spark plug, and then he'll say, sir or madam, now I have to open the engine, some engine problem, because all this I have checked, etc. There is a sequence of steps in which your mind works. There is a procedure in which your mind works. The same procedure you feed into a machine, and this is artificial intelligence. Okay. Now, how does artificial intelligence work? It works in forms of algorithms. Algorithms are like equations. It is a set of rules to be followed or some problem-solving operations. What I just now told you was an algorithm. Your bike is not starting, check ignition. Bike started, stop. Second, bike is still not, second case, bike is still not stopping, check your petrol. Okay, bike started, stop. Again case, bike still not starting, check your spark plug. You see, a series of steps. So algorithms play a very important role in the structure of artificial intelligence, because this is the way we teach people, machines to think. People think, but machines need to be taught to think. And how do you teach them? By saying, do this, if this, stop. If not this, go here. Do this. If this is okay, stop. If this is not okay, go to the third step. Do this. If this is okay, stop. You understand? So this is a simple algorithm. I have written here expert systems because expert systems are sort of a weak artificial intelligence system which does what it is taught. All right. Now, next one. The major concepts closely related to artificial intelligence are, see, you may think why ma'am is talking so much about artificial intelligence before and why she's not talking about selection. See, when I tell you what it is and how it is used, you'll naturally relate it to different aspects of human relations, human resources, different aspects that are necessary in recruiting, selection, mapping, human resources, mapping, etc., that comes in prediction. So first you have something called machine learning. That is, computer programs can automatically learn. How do they learn? They just copy. They just read and they are programmed to copy. So once it is a program, they are programmed to copy, they copy it and they, automatically. See, you add more code, no? You have, you say some coding is done and it is already there. Then you add some more. So the machine becomes smarter by learning. So this simple machine learning, for example, image recognition. Image recognition is one of the most best uses of machine learning. You see this. See, when you talk about pictures, we talk in terms of pixels, Pixels. All right. So a picture has so many pixels, something like that we say. Look at this picture I have given you. You see one eye, for example. There are so many numbers, everything. See, in the computer, everything is stored in the form of numbers. So you have a lot of numbers here. See, if this pattern, you see a matrix here in the cube, you'll get a particular pattern of numbers. You'll get 208, 126, comma 83. You'll get a pattern like an ordered pair, it goes on. If this pattern comes, then the machine says a dog's eye. If this pattern comes, a dog's eye. Hello, is there a problem? Satyanarayan sir, can you hear me?
Go ahead, madam. Go ahead.
Yeah. Yeah. So you can also say, if you see here 208, 126, 83, instead of 208, if there is 206, 124, 81, then it is a Pomeranian dog's eye. Suppose there is 205, 120, something like that. It's a Labrador dog's eye. You understand? So when the program is there, so suppose this what you see here is fed into the machine, it will say like is equal to Pomeranian dog's eye. It's the eye of a Pomeranian dog, eye of a Labrador, eye of a German Shepherd. Now look at the next picture. You can see a picture of a dog, I hope. If you go right back, you can see. If you see close by, it's not very clear. You see, everything is in pixels. Every number the computer identifies. It's a huge amount of data, but the computer system can manage it. So this is how artificial systems are programmed to understand, to recognize a picture. And we say facial recognition. If you see my face and when you take a picture, it is full of numbers. The memory is stored like this. That is how a robot will say, oh, this is ma'am. Okay, something like this. So speech recognition. Speech recognition is the translation of words into text. Have you heard of Siri? On on my phone, you have Siri. See, I'll say, look at Siri. Morning, Siri. How are you? One second. Good morning, Siri. Siri is stubborn today. Sorry. Hello, Siri.
Hello.
Good morning, Siri. Good morning, Siri. Sorry. Good morning, Siri.
And good morning to you too.
See, these things, it is programmed. When I say good morning, it will say good morning. Let us try something else. How much is 2 plus 2, Siri?
That would be 4.
Yes, she told me 4. Now you see, how much is 2000 plus 2000, Siri?
The answer is 4,000.
Okay. Now you see, how much is 2000 into 2000?
Here's what I found.
She cannot understand. I said 2000 into 2000. So the program hasn't been fed into her to 2000 into 2000. Now I will say 2000 multiplied by 2000. Siri, how much is 2000 multiplied by 2000?
The answer is 4 million.
You heard, I think, no? When she's been programmed to say for 2000 multiplied by 2000 is 4 million. But when I say in colloquial terms 2000, you and I would understand why 2000 into 2000 is same as 2000 multiplied by 2000. But Siri is programmed to say 2000 into multiplied by 2000 into 2000, she cannot figure out. So like this. And she doesn't answer on my phone for anybody but me. So I have spoken into my phone and my phone has recognized my voice and she answers only to me. All right. If anybody tries, she won't answer. So this is voice and my voice is converted into text. Whatever she says, whatever I say will be there, will come, you know that, I think. Okay. Now, in medical diagnosis, this is very important. See, artificial intelligence. See, for example, 2 years ago, I had a stroke. One little blood vessel here burst and I had a leak in my brain. So when they did MRI, they found a leak of blood in my brain here. So they said I had lost the use of my left arm and left arm and leg. So they diagnosed because of this, because the blood leak has gone into the right side of the brain. So opposite, the left arm and the finger is not working. So they treated me accordingly. They treated me that I would not lose more blood, that no more blood would leak, something like this. So suppose there was a clot there, they would see, in artificial intelligence, it would tell. And diseases. For example, if there is a tumor, a particular tumor is, has certain, for example, dementia. In dementia, what happens? Old people, they start leaking, some kind of fluid, and their blood vessels will start bursting, small amounts of blood in the brain. Or there is fuel in accumulation, means in the brain means something else. So artificial intelligence will give you the reports, because if this is there, if the presence of fluid is there, then this disease. If the presence of clot is there, then this is the result. If the presence of blood is there, this is the result. So in medical diagnosis, artificial intelligence is very important. Now, another importance of this is here, statistical arbitrage. It is based on the assumption that in pricing in financial markets, there is inefficiency. So what are you going to do? I explained to you how SEBI works, isn't it? So similar way, artificial intelligence works. Now look here, look at this particular GIF that I have brought. As I told you, a dog's eye, how the input happens, how the machine, understands it, how it relates to, this is the input, this is my database, I will relate it here, and what I've related, I will give the output. Okay. So also associations, this is also for associations. Let us go ahead. It also helps in classifying whether it's a dog or a cat or a human being. It helps in predicting a dog will bark, a cat will mew, a cat will scratch you, a dog will bite you, something like this. Okay, then extraction, all this. Extraction means, I'll give you an interesting example. There is something called data mining. IBM, it seems some years ago, this case study is nearly 10 years old or more. IBM was supplying the cable TV network in the UK. In the United Kingdom, in Britain, it was supplying the cable TV network was supplied all over by only IBM, only one cable network supplier. So IBM was making huge amount of profits. And then IBM thought, I must give back something to the British people. I must enhance their experience. From being satisfied, they must get a delighted experience. So what IBM did, it started data mining, meaning suppose there's an Indian household. What do they watch? It made a study. Mostly it was Hindi movies and Indian cricket, mostly, imagine. So they knew that from their research, they know that, say at that time, Sachin Tendulkar was the hero. So they knew that everybody is interested in Sachin Tendulkar. So because of the data mining, what they did, for example, see, I'll give you this example. When you see some TV series, like say Friends TV serial, in the middle, they'll give one something like friendly fact or something. They will give something about the actors, that the actors were all united, that the actors are getting so much money in some years. Now they're getting so much money because since you're a fan of the Friends serial, some little tidbits like this are interesting for you. So if you are a fan of Sachin Tendulkar, what IBM was doing is, in the screen, you get Sachin Tendulkar playing, no? In one corner, they'll give a square where they'll show Sachin Tendulkar when he's relaxing. Maybe he's wiping his nose, maybe he's laughing, he's telling his friend a joke and is laughing, something like this. So some personal glimpses of the star were given in the screen. So this is what I want to say is an example of extraction. You are given what you like. So when suppose I'm interested in cooking, and I have looked into one one website where there is I have looked into some recipes. So when you see in your browsing history, and due to cookies, it is recorded. So you will see similar interest, what coming up when you browse. So this is also because of this is one example of extraction and artificial intelligence example. Next, you have deep learning. The best here is self-driving cars. How do you do self-driving cars? The computer, of course, there are sensors. Have you known that bats are blind? Bavli, Kannadadalli Bavli antaralla. So avrige kannilla, Bavligalige kannilla. So how do they fly? They fly because they give sensors, it seems, like rays of light everywhere. If the ray of like radars, say I'm going and as I go, I give a shoot out a ray, and the ray hits one object. Oh, there is an object and comes back. Then there's an object here. I turn left. Left is okay for me. Something like this. It goes on. You see? So it keeps on shooting out rays, it seems. And when the rays bounce back, they say, no, object is there. I should not go this side. I'll go this side, like that. So similar thing with self-driving cars. Let's imagine the car has started and the sensors are saying nothing in front. It is shooting rays and it's going. And maybe it could be sound rays. It could be light rays. or it's going. Imagine, and suddenly there is a person crossing the road. Your ray that the car has shot has come back. Then the car slows down. Okay, and it is shooting rays not only from top, it is shooting rays from down. So one ray goes and says the road is up, it has come back. So there is a hump, I have to go slowly. The ray has not come back at all. Then there is a depth in the road. After the car will automatically be told. When the ray doesn't come back, reduce the speed. So the speed is reduced. When there is, the ray comes back very fast, brake quickly, press the brake. So something like this happens. This is the way the, self-driving happens. And this is another example of artificial intelligence. We have the next thing is natural language processing. I just demonstrated you on my phone how Siri works. Okay, we have virtual assistants, Siri, Amazon's Alexa. Yeah, for entertainment, we have virtual reality, where you have you're driving a car and you hit something and then again your car turns, you come back, something like this. These are any kind, all the computer games, the whole gaming industry is based on the artificial intelligence and virtual reality. Then visual recognition, fraud detection, I told you this, healthcare, etc. Okay, so we have here again, see email filters, how email filters happen. Email filters also happen because of this. Something goes to spam, something not admitted goes to spam, isn't it? Okay, then you have search results, search engine optimization. And what is search engine optimization? See, suppose I'm searching for I'm searching for a recipe to make udin vadas. Okay, so what would I put in as udin vada, for example? So there is a, or I may say, things like, what are the keywords I'm going to use when making the search. So the keywords are, you ask 4 or 5 people, and what is the common keyword that you use? That common keyword will be used in the content that is presented. Suppose I'm giving a website. Suppose I'm giving a website, I'm in a session. Suppose making a website, and for the website in the front, there is some write-up I have to give. So the keyword I discovered in research by talking to 4 people. See, 4 people gave me, 3 people gave me the same word for Udin Vada. They would use VADA. Okay, they would not use Udin Vada, they would use VADA. So in my sheet, I would put VADA because when the search engine searches, my screen, my website will pop up first. So this is search engine optimization. Okay, so all this, is digital phone calls. Like if I tell Siri call Satyanarayan sir, it will call. Siri call Anita ma'am, I will have to tell, suppose I have kept Anita ma'am's number as Anita ma'am, Davangere University. So I have to tell in the same way, Siri call Anita ma'am, Davangere University, and Siri will call on my phone. You see? So, but you have to use the same words. So that is why, it is human language, as close as human language as possible, but the word should be same because it's a machine. It's not, it won't understand that, suppose I say, call Dr. Anita Professor, this will not understand. Suppose what I wrote only, it will understand. A human being would understand. So data analysis, text analytics, all this. See, sometimes, a lady called me from.
Anita, ನಾನು ವರ್ಕ್‌ಶಾಪ್ ಅಲ್ಲಿ ಇದ್ದೇನಮ್ಮ, ಆಮೇಲೆ ಕಾಲ್ ಮಾಡ್ತೀನಿ.
Hello, any problem, sir?
Sirappa sir, mute ಮಾಡ್ಕೊಳ್ಳಿ.
Okay. Now suppose, see, a lady called me and I gave a talk last 15 days ago on issues of sexual harassment prevention. So I had not stored her number, but I remembered her name as Bindu. So in the conversation, like I had called her something else. I had called her something with B only. So she says, no, ma'am, I'm Bindu, she told me. Then I had not stored her number as in her name. So when I wanted to find out where is it in the conversation, I put Bindu. My phone found it out. Though she, in the contact, I don't have any Bindus. My phone found it out that in the conversation there was a Bindu and it threw up the conversation. So I could easily get her number because when I wanted to talk to her again. So all this is weak kind of artificial intelligence. I showed you the demonstrated Siri, because when I said 2000 into 2000, it didn't give me. It was not able to understand. It threw up some different kind of things like metric system, how to convert, all that it gave me. But when I say 2000 multiplied by 2000, it understood. All right. Nice. Artificial, okay. You just see it, how this, I've given you a GIF on face recognition. The other things are all same, like goals are of artificial intelligence are learning, reasoning, and perception. Let's go ahead. Wait. Okay, we have time. Now, see, weak artificial intelligence systems have less programs in it. Strong artificial intelligence system have more data and more programs in it. Now, whatever we say, a benchmark. There is something, a virtual assistant on my phone who can talk to me. That was a benchmark. But as technology advanced, these benchmarks, became run of the mill for everyone. There were new benchmarks formed because new kind of coding developed. So machines that calculate basic functions or recognize text through optical character recognition, like what I just showed you, Siri, these are all supposed to be weak artificial intelligence system. Now, here I have something continuously evolving. We require a cross-disciplinary approach. Why? Imagine I'm a robot, okay? I'm a robot and you're talking to me and then I start turning my head. If I'm a human being more than this, I cannot. Imagine I'm a robot and as you're talking to me, I start turning and it goes 360 degrees. What will you say? Ghost? Deva? Isn't it? So what I'm trying to say is, now you look at my hand. Can you turn it 360 degrees? Yes. Why? I have some kind of bones here, which are like balls. I can turn it like this. Same thing can you do with this? Can you turn it like how you can turn here? You cannot. Can you do with this? Yes, you can. What you can do here, you can do here, but you cannot do here. Okay? Now see, this is anatomy. What I just told you is anatomy. Okay? Now, what happens is when you're making robots, you have to understand anatomy and make. You know that human beings cannot turn the head 360 degrees. You can only turn from here to here, 180. But if you make a robot that turns its head and it looks like a human being, then what panic it will cause. So this is only a small example of telling you that artificial intelligence systems coding has to combine with anatomy. So similarly, it has to combine with mathematics It has to combine with linguistics, how to talk. But if you have a robot which looks like me, I'm an Indian. I must talk in how an Indian talks. I'm not born and brought up in England to have that English accent or an American accent. I have a Bangalore accent. I'm born and brought up here. If you have my color, brown color, and you have an American accent, if you say this is a Bangalore-based robot, me, and I have an American accent, then it wouldn't match. So linguistics is also important, and psychology, etc. Now, artificial intelligence, there are 4 types, okay? Reactive machines, limited memory machines, theory of mind, and self-awareness. As you have Abraham Maslow's this thing, no, that pyramid. So you start with roti, kapda, makan. So unless you get your roti, you get your kapda and your makan, you cannot go up, for example. Like basic needs are first, your hunger has to be satisfied. Then you
Hierarchy
have
theory.
to clothe. Hello?
Hierarchy theory.
Yeah, hierarchy theory. So you, unless you eat, if you don't have food, you can't think of anything else. All you can think is, I'm talking to you and I'm thinking I'm hungry. Okay, then food, clothing, and then I have to be comfortable. There has to be a roof on my head before I can think of something else. So similarly, this also machines go like that. The self-awareness comes last. So we have the reactive machines, which are the most basic types. They are purely reactive and have the ability, like here, see, you click, oh, this fellow, no, this robot is called Pepper. And he sells for some, I forgot the money. This Pepper is a robot which is being sold. If you check BBC, you'll see. Okay, so they can see, and they have the ability, do not have the ability to form memories or to use past experiences. See, this is one important concept. I told you, can machines learn? And I said today, machines can learn. If they can record the situations that they come across, and they can put it in their database and connect it with an algorithm to connect this recent experiences with future experiences, then that is learning. I'll give you an example. I will give you, see, if I say this, what is it? Describe this. You'll say, ma'am, it is a glass. Is it transparent? It is transparent. What does it contain? Obviously, water. All right. If there was orange color, you'll say, ma'am, must be juice. Must be mango juice, you'll say, because now it is time for mangoes. Must be mango juice, ma'am, you're drinking. So this is obviously water. Why? Why did you say it's water? Because your memory says if it is transparent, translucent liquid, it must be water. You have a memory. You have stored it in your memory. Every translucent liquid must be water, basically. Then you'll smell it. If I smell it, it has no smell. Obviously, it is water. Then I will drink it and see. But if it smells different, I will not drink it. All right. Suppose the water is dirty and it smells bad. I'm not going to drink it. So why? Because my memory has been told, drink only clean water. And how do I understand clean water? Which has no smell, which has no taste, is this thing. I drink some water and said, hey, it is sweet tasting, must be well water. Yeah. So we know that well water tastes different, for example. Okay. So this, if you, I was telling you in my second slide, can machines learn? Yes, machines can learn if they are programmed to record whatever situations they are going through, keep it and connect it to the database that they have and react to it. And they have told their algorithms are there to tell them how to react to it. Then machines can learn. Okay. If I give you, say, for example, when I was a Girl Guide, we had one interesting test. ma'am had given us one interesting test. She kept glasses of water and she said, I've put something different in each glass of water. Excuse me. I have put something different in each glass of water. So we have to take a spoon and we have to put in our mouth and taste. So when I was tasting something, I looked at my friends' faces and they said, So obviously I drank and it was salt water. And when I was doing another one, I said like this. So it was sweet water, sugar. So there was water of coriander powder and something like that. Ma'am wanted us, it was some kind of test, some perception test. But how do we know? Think of us as machines. How do we know that it is sugar? Sweet, I got sweet taste in my mouth. Sweet means sugar. I'm associating. So similarly, this happens with reactive machines. Next, limited memory. Here, self-driving cars. See, self-driving cars can go on the road. They can't fly. They can't fly because they don't have the propeller, whatever you require. But it also is programmed to be on the road. It can sense the road. There are sensors which look down and sense the road. Sensors which go left, right. On my right, there is a car. On my left, there is a car. How much distance is it? Is it coming too close? Can I go left? You shoot a sound signal and you find that it is coming back too fast. So the car on my right is very close by. I must shift to the left. Before that, I will shoot an arrow this side of say sound or something. This arrow has not come back very fast, which means I have space here. So I can shift myself to the left. So this is how it goes on. So but it is limited memory. Okay. So next we'll go on to theory of mind. You see here, they say if you have artificial intelligence development, this is a picture for time travel. This GIF here is a picture for time travel. It is an important divide, they say, between the machines we have now and the machines we are going to build for the future. So imagine a time traveling machine. You can go and see your grandfather when they were a child. You can go and see your great grandmother whom you have never seen. You can go and see your future grandchild. Yeah. See, today it might say what ma'am is talking, silly. It is against nature, it is against science. But think of the possibilities. Did you ever think, see, when I was in